Hello, I'm Seema and welcome to part 3 of the chapter Alcohols, Phenols and Ethers. We were discussing the nomenclature of alcohols and phenols in part 2. So moving ahead with our discussion of nomenclature, in this video we are going to talk about the nomenclature of ethers. As you already know, ethers are alkoxy derivatives of alkanes. In other words, they have a general formula ROR. Right? The general formula is ROR or ROR dash. It could be ROAR or it could be AROR. In other words, where AR and R are aryl groups and alkyl groups. So you say that if this is the alkane, this is the longer chain hydrocarbon, then this is the parent alkane and this part becomes alkoxy group. Just as we have the methyl group, if one of the hydrogens of the methyl group is substituted by oxygen, we would call it an alkoxy group. So it becomes an alkoxy group. So an alkyl group with an oxygen would be an alkoxy group. So you choose which one is the parent hydrocarbon and which of these R's becomes the alkoxy group. In that way, we say they are alkoxy derivatives of alkanes or arenes. Alkoxy or aryloxy derivatives. It's just a little confusing when you talk like that. When we do the nomenclature, it will become very clear to you. So the general formula of ethers is ROR dash. Now, how do we name them? Is our problem. In common nomenclature, the alkyl groups, both the alkyl or the aryl groups, are named in alphabetical order. And the word is ended with ether. For example, look at this compound. CH3 is a methyl group, OCH3. So both the groups are methyl groups. And in the middle, you have oxygen, which means it is an ether. So we will call it dimethyl ether. Let's take something different here. Look at this one. This has got a methyl group on one side and it has got a propyl group or propyl group on the other side. So alphabetically, which comes first? M or P? L, M, N, O, P. M comes first and P comes later. So we have two alkyl groups, methyl group and propyl group. We'll write methyl propyl ether. That is how we will name it in common nomenclature. Methyl propyl ether, methyl, and we write N-propyl. Do you see N? Normal means a straight chain. That the first carbon of the propyl group is attached to oxygen. If it was the second carbon, it would have been an iso compound. You remember? So when you're choosing the alphabetical order, we do not choose N for that. We have to take the propyl word into consideration and you choose the alphabet or the alphabetical order from propyl and not from N. This becomes clearer when you take another example here. In this example, take a look. This is methyl and this is isopropyl. This group is isopropyl. Why iso? It is a propyl group. It has 3 carbons, but the second carbon is attached to oxygen. So this is a propyl group. Again, but it is an isopropyl group. So according to alphabetical order, again, methyl comes before P, M comes before P. So we'll write methyl isopropyl ether. If I had considered the I of the iso in alphabetical order, isopropyl methyl ether would have been the name of the compound, which would then be wrong. So even in common nomenclature, you have to keep this in mind that it is not the iso, the prefix like iso, whether it is normal or it is neo, that alphabet is not considered in the alphabetical order. Only the name of the alkyl group or the aryl group, that is taken to choose the alphabetical order. So let us, from this you easily understand that in common nomenclature, how do we name ethers? We write the names of both the alkyl groups in alphabetical order and we add the word ether to it. So the name has 3 words, one alkyl group, second alkyl group and ether, alkyl or aryl group. But in IUPAC nomenclature, we go according to the rules. What are the rules? The first thing is we choose the hydrocarbon which is the parent hydrocarbon, which has the longest chain. So we choose the longest chain hydrocarbon and we consider this the other part, that is, if you take a look at this, let us choose this again because there's a difference in the two sides. This is a methyl group and this is a propyl group. In IUPAC nomenclature, I'll choose the longest chain as the parent hydrocarbon, which means 1, 2, 3. This has 3 carbons, this has only 1 carbon. So I choose this to be the parent hydrocarbon. So this becomes propane. I consider that this is a compound, the parent hydrocarbon is propane, and this methoxy group is the substituent. So the smaller alkyl or aryl group with the oxygen is called alkoxy. Alkoxy derivative of alkane. Now you understand the word that I said. They are, what are ethers? Ethers are alkoxy derivatives of alkanes. Which means that you take, this would be methoxy and the parent hydrocarbon is propane. So in IUPAC nomenclature, we will call this methoxy propane. Right? And what would be the position at which carbon? If you take a look at the other one where we had this is also methoxypropane, but according to IUPAC nomenclature, you have to give a look and you have to tell to which carbon of propane is the methoxy group attached. In this, it is the second carbon to which methoxy group is attached. So this would be 2-methoxy propane, while this one would be 1-methoxy propane. If you do not write the 1, it is understood that it is the first carbon. But these days, it is preferred to write it rather than assume that the person would just guess it. Although it is very clear, whenever you don't write the locant 1, it is automatically understood that the locant should be 1. That is why you did not feel the need to mention the number. So now that we know how do we name them, we will be writing down the names, common names and the IUPAC names. I'll be explaining each one to you. And let me again read the rules. In common nomenclature, what do we do? The alkyl or the aryl groups are written in alphabetical order separately. And then the word ether is added to it in the end. Methyl, ethyl, ether. If they are both the ethers or if both the alkyl groups are the same, then it will become dimethyl ether, diethyl ether, as you will see here. And in IUPAC nomenclature, they are alkoxy alkanes. The alkoxy derivatives of alkanes. Right? So alkoxy becomes the substituent and alkane is the parent hydrocarbon. Remember one thing, that ethers in IUPAC nomenclature, alkoxy or phenoxy is always written as a prefix. It is never written as a suffix. As in the case of alcohols, what we did, in the end of the alkane, we removed the E and we wrote all. Alcohol. So we have in the end. So that is a functional group which is written in the end as a suffix. Such functional groups are more important than the ones that are written as prefixes. But anyway, when we write down the name, if you remember IUPAC nomenclature that you did in grade 11, there is a series of, there is a preference according to which you name the hydrocarbons. And this series of preference in the case of suffixes, alcohols, carboxylic acids, whatever functional groups you have, they have a fixed list of priority. But in the case of prefixes, prefixes 1 are treated as substituents. So we say they are alkoxy derivatives, right? So they are treated as substituents, and these substituents, they are always written, their order of preference is in the alphabetical order. When you choose which one is more important, what should I give a lower locant to, you will choose the one which is smaller in alphabet. This is really interesting. You might find it a little confusing, but as I do these examples, this is going to become very clear to you. So, let us start with the first compound. CH3OCH3. There are 2 methyl groups. So in common nomenclature, this will be called dimethyl. Both are methyls. So dimethyl end with ether. In the case of IUPAC nomenclature, we have to choose one of these as the parent. So I choose this as the parent. So this becomes methane. And this part, the substituent, becomes methoxy. So it becomes methoxymethane is the name of IUPAC name of this compound. Take the second ether now. C2H5O C2H5. Again, it is a symmetrical ether. Both the alkyl groups on both the sides are the same. So in IUPAC nomenclature, in common nomenclature, we will call it diethyl ether because both of these are ethyl groups. But in IUPAC nomenclature, what will we say? We'll take this as the parent, so this becomes ethane, and this becomes the substituent, so it is ethoxyethane. Clear? Come to the third compound. CH3O, CH2, CH2, CH3. So this is propane or propyl group, and this is methyl group. Now, even in common nomenclature, which one will come first? In common nomenclature, we write the names of both the alkyl groups and we end it with ether. So I told you, when we are writing down the names of the alkyl groups and when they are different, we have to do it in preference of in its alphabetical order. So this is methyl, this is propyl. M comes before P, so it is methyl N-propyl ether. Although N also comes after LMN, N comes after M, but we are not considering the N. In alphabetical order, I have to choose the propyl, the P of the alkyl group. The first alphabet of the alkyl group, not this prefix, which tells you which carbon is attached. So this would become methyl N-propyl ether. And in IUPAC nomenclature, how would I name it? This would be 1-methoxypropane. Do you see? This is propane. My parent hydrocarbon becomes this. I just explained it to you a little while back. This is propane. And this is the substituent, which is methoxy, and it is attached to the first carbon, so we write 1-methoxypropane. Come to the next compound, compound 4. C6H5OCH3. Now this is a phenyl group, right? C6H5 is a benzene ring. Then OCH3. This is the methyl group. MP. Which will come first in common nomenclature? M will come first. So it is methyl phenyl ether. Right? Methyl phenyl ether or phenyl ether. The common name, one common general name that is given to this compound is anisole. And anisole is a name that has been adopted by IUPAC nomenclature also. So sometimes in IUPAC nomenclature you can write anisole. But if we go by the rules and we are trying to name it strictly by the rules, what would the parent hydrocarbon here be? This, according to IUPAC nomenclature, the parent hydrocarbon would be the one with the longest chain, with the longer chain of carbon atoms. This has 6 carbon atoms and this has only 1 carbon atom. Automatically, this becomes the parent. It's larger. So, C6H5 and this is CH3. Not trying to sound condescending, but children, the parents are larger, so they are, no, but yet the preference is for the longer chain. So C6H5, this becomes the phenyl group or the phenyl group or the benzene. That becomes the parent hydrocarbon, and this part becomes the substituent, which is methoxy. So how would you name it? This is methoxybenzene. Methoxybenzene. And anisole is the name that has been adopted by IUPAC also. Next compound. C6H5, again a benzene ring. O, CH2CH3, this is ethane or ethyl group. Again, in common nomenclature, this will be ethyl phenyl ether. Because E comes before P, so it is ethyl phenyl ether. And it has also been given a general name, which is phenitol. Not commonly used, honestly. This is not very commonly used, but ethyl phenyl ether. And this name has not been adopted by IUPAC. IUPAC is a little stingy with what it adopts. It only adopts certain names which are kind of so common that it would not harm to use them. So this is phenitol, ethyl phenyl ether. But in IUPAC nomenclature, this is the parent and this is the substituent. So what is the substituent? Ethoxy is the substituent and benzene is the parent. So we write ethoxybenzene. Come to the sixth compound. C6H5O CH2 whole 6 CH3. Which means that on this side there are 6 plus 1, 7 carbon atoms. So it is heptane or heptyl group. And on this side you have 6 carbon atoms. So it is the phenyl group. So H and P, which comes first? H comes first. So in common nomenclature, we'll write it as heptyl phenyl ether. Easy? Heptyl is this part, phenyl is this part, alphabetical order, end it with ether. But in IUPAC nomenclature now, the phenyl or the benzene is not the parent because this one has 7 carbon atoms. So this is longer, it's a longer chain. So this becomes the parent and phenoxy becomes the substituent. So we have heptane and phenoxyheptane will be the name of this compound. And again I'll write 1. Why? Because it is attached to the first, we'll start counting from this direction. So it is attached to the first carbon of heptane. Then compound 7. This is CH3O, methyl group on this side, and this is isopropyl. So when you have to name it, again, it'll be methyl isopropyl ether. If I had considered the I of the isopropyl, then I would have written isopropyl methyl ether, which would be wrong. You never take the prefix of the substituent when you are choosing the alphabetical order. The prefix of the substituent is only telling you the position or the bonding of the substituent. It is not actually affecting the name of the substituent. So the name, the size of the substituent, or not the size when we are talking of alphabetical order, it's just the nature of the substituent. So this becomes, what will be the correct name? It will be methyl isopropyl ether. And in IUPAC nomenclature, what is the parent? This is 3 carbons, this is 1 carbon. So this is methoxypropane, but the locant for propane, methoxy, is attached to which carbon? To the second carbon. So we'll write the locant before the substituent. So it will be 2-methoxypropane. 2-methoxypropane. So methoxy group is attached to the second carbon atom. I have a terrible back pain, so excuse me if I cringe with a little pain now and then. Okay, carrying on with this now. The next compound, C6H5O CH2, CH2, CH, CH3 and a branch CH3. So this side, according to IUPAC nomenclature, this is 2-methyl-butyl, or no, 3-methyl-butyl. Okay, and what is this? This is benzene, 6 carbons. So this will be the parent and this will be the substituent with another substituent on it, a methyl group. In case of IUPAC nomenclature, these methyl groups which are branches are treated as substituents. But in common nomenclature, what is this? This is isopentyl. Why is it isopentyl? Because there's a branch on the second carbon. Since there's a branch on the second carbon, it is isopentyl. This group is isopentyl. So it is phenyl, isopentyl. Now, phenyl isopentyl ether is the name of this compound. You could have written it as isopentyl phenyl ether also. Anyway, since the book mentions phenyl isopentyl, I will not try to confuse you here. Phenyl isopentyl ether. If I was given to choose the nomenclature here, I would have, when the first alphabet is the same in both the cases, both it is P, then I would have gone to the second alphabet, H and E, A, B, C, D, E, F, G, H. So I would have chosen phenyl to come later and isopentyl to come first, but then the book mentions phenyl isopentyl ether, maybe that is how it is named. Common nomenclature does not always follow the rules. So we accept it like that. And what is the IUPAC name of this compound? For the IUPAC name, we'll take C6. This has 6 carbons, so it is benzene is the parent hydrocarbon. On the third carbon of the butyl group, there is a methyl. So we'll say 3-methyl butoxybenzene. 3-methyl butoxybenzene would be the name of this compound. This is butoxy group. And on the third carbon, we'll treat this as the first carbon which is attached to oxygen. So 1, 2, 3, the third carbon has a methyl group attached to it. So it is 3-methyl butoxybenzene. Next compound, CH3O, CH2, CH2O, CH3. There are 2 alkoxy groups here. So it is a diether. If you really see, it has got 2 alkoxy groups. So when the compounds get a little more complex, common names might be missing because the confusion had already started here. So now for the next 2 compounds, there are no common names. We just go to the IUPAC nomenclature. This would be 1, we treat this, where is the parent hydrocarbon? This carbon and this carbon is the longest carbon chain that I can see, because here it comes, oxygen comes in between. Here also oxygen comes in between. So I treat this as my parent. So this is ethane. Ethane is my parent, and on both the carbon atoms of ethane, 1, 2 dimethoxy. Both of them have methoxy groups, so I'll say 1, 2 dimethoxy ethane is the IUPAC name of this compound. Alright, so let us now come to this 10th compound. In the 10th compound, take a look. This is cyclohexane. It has got 6 carbons. 6 corners, so 6 carbons. This is ethoxy, C2H5O, and these 2 are methyl groups. In IUPAC nomenclature, when we write down the names of substituents or some substituents which are always written as prefixes, we always write the prefixes in alphabetical order. When we are giving the locants, we follow the lowest sum of locants rule. But when we are writing the names, should we write both methyl and ethoxy? Both are written as prefixes. So which one do we write first? Do we write ethoxy first or do we write methyl first? We write it in alphabetical order. So we'll write, this is methoxy dimethyl, ethoxy. It's ethyl group. So ethoxy, because E comes first, ethoxy dimethyl cyclohexane. Alright? It is ethoxy dimethyl cyclohexane. Now what are the locants that we will get? According to locants, you will follow the lowest sum of locants rule. If you look, methyl group does not seem to be as reactive as OC2H5 because this looks like a functional group. It has an atom other than a methyl and an alkyl group. So it appears to be more reactive. So we might think that we would like to give OC2H5 the lower locant so as to show that we are giving it importance. But if we give this as 1 locant, then the 2 methyl groups will get 1 ethoxy, 2 dimethyl. So what is the sum of locants? 1 plus 2 plus 2, 5. But if I give the methyl group's locant 1, if I treat this as first carbon, then we have 1 dimethyl, which means the sum of the locants is 1 plus 1 is 2 plus 2 is 4. So that numbering would be correct. So we will give the locants, we will give both the methyl groups the locant 1 and the ethoxy will give it the locant 2. Right? Now let me take a color pen. So this would be 1 and this will be 2. Now when we are naming the compound, we have to write ethoxy first because ethoxy is alphabetically smaller than methyl group M. E comes before M. So it will be 2 ethoxy hyphen 1 dimethyl cyclo. Whenever there's a cyclic compound, you have to write the word cyclo before the parent hydrocarbon. So it is cyclohexane. There should be, remember when I'm writing the names here, I usually, in the end, I have put a hyphen. In IUPAC nomenclature, actually, you have to write, there should be no gap once you start writing the name. Only for locants, you put a hyphen, you give a number, you put the comma or whatever, but you write the name in one line. Due to dearth of space, I've written it like this. Actually, there should be no hyphen. The heptane should come right here. Similarly, for methoxy, the propane should start right here, propane. Here also, methoxy, the propane should start right after Y. There should be no gap. Just, I have to make this clear because what I have written is only because my line was in the middle and I wanted to write more compounds to prepare my board. So here also, dimethyl cyclohexane will all be one long word. There will be no hyphen in between there. This hyphen is because I am continuing the name. So now, this is example, the solved example of your textbook. It says, give the IUPAC names of the following compounds. So this has alcohols, phenols and ethers. In this video, I will only be doing these 4 names more, and I think looking at the questions and the text exercise questions also, I might do another video or maybe 2 videos now doing nomenclature. I had not thought that I will be doing it in so much details, but yes, I think it would help to do all of it. So now you take a look at the first compound. What is the functional group here? The functional group is OH. It's an alcohol. There is a chloro in it and there are 2 methyl groups, right? So how would I write the IUPAC name? What is the longest chain? 1, 2, 3, 4, 5. So this compound is pentane, right? Pentane has 2 methyl groups, 1 chloro. It has 4 substituents. 2 methyl groups, 1 alcohol and 1 chloro. So from which direction will I start counting? I'll start counting from this direction because alcohol is a functional group. It is not written as a prefix. I will try to give the alcohol the lowest locant. So I'll take this carbon as first carbon, carbon 1. Oh. This will be my carbon 2, 3, 4. All right. So when I name this compound, I'll name it as, again, these are methyls and this is chloro. These are all prefixes. So C comes before M, so I'll write chloro first. So it will be 4 chloro, 2, 3 dimethyl. Again, see, my space is less. I should write 1, 2, 3, 4 butane, butane, 1 all. Okay? 4 chloro, 2, 3 dimethyl butane, 1 all will be the name of this compound. Coming to the next one. CH3, CH3, O, CH2, CH3. This is an ether and we've just done ethers. This is isopropyl. You remember common nomenclature? Isopropyl. But here we have propane or propyl group and here we have ethyl group, which is the parent, the one that has the longer chain. So this becomes propane. Propane is my parent hydrocarbon and ethoxy becomes the substituent. So I write, and since the ethoxy group is attached to the second carbon atom, not the first carbon atom, so we write 2 I pick up the wrong ethoxy, 2 ethoxy propane is the name of the IUPAC name. Again, I think I took the wrong pen. Are they playing games with me? They work and they stop working. Anyway, next compound. This is benzene ring. It has OH here and 2 methyl groups attached. You know, when you have OH group attached to benzene ring, it is called a phenol. So this part is already named phenol. We have to give the locants to the 2 methyl groups. So if this is alcohol, OH, this becomes the first carbon. You can start counting from any direction. Oh, this is not writing at all. What's happening? So this is carbon 1. Yeah. So this becomes carbon 2, 3, 4, 5 and 6. So 2 and 6. So I'll write 2, 6 dimethyl. 2,6-dimethyl phenol. I need a new pen. That becomes the name of this compound. And the last compound for today, you have nitro group attached here. Nitro group is also always written as a prefix, remember. And this is ethoxy. And this is cyclohexane. So cyclohexane is your parent hydrocarbon. You have ethoxy and nitro. Which comes alphabetically first? Ethoxy comes first. So I will, since ethoxy comes first, and if I give the locants in this direction and this direction, in both the cases the sum of the locants is the same. If I write 2-ethoxy nitro cyclohexane, or I write 1-ethoxy nitro 2-nitro cyclohexane, the sum of the locants will be the same. So what should I choose? From which direction should I start numbering? Or should I start, which should get the lower locant? The ethoxy or the nitro? When both are interchangeable, or when both of them in both the directions have the same locants, then you should choose the lower alphabet to have the lower locant also. I hope I'm clear. See, if I had written, there are two possibilities. Let me write both the names first. This is 1-ethoxy, 2-nitro, okay, cyclohexane. And the second option would have been 2-ethoxy, 1-nitro, cyclohexane. Cyclohexane. Tell me, why did I wipe off the comma that I had put here by mistake? The comma you write only if you have more than one locant. Otherwise, between the locants and the name there should be hyphens. By mistake I put a comma here, which I had to wipe off. Anyway, so these are the two names, possible names. Which one is the correct one? Since both have the sum of the locants, this is also 2 plus 1, 3, this is also 2 plus 1, 3. But since I am writing ethoxy first in alphabetical order and nitro later, if I have the choice, I will give ethoxy, since both the locants, sum of locants is the same, I will give ethoxy the lower locant, so that it is lower alphabet, lower locant also. It would be better, there would be more symmetry. And the second name I would not choose. So the name of this compound would be 1-ethoxy 2-nitrocyclohexane. So with this, I'll wind up today's video. If you wish to watch other videos of this chapter, please click the link that appears on top of the video. In the next video also, we'll continue with nomenclature, and I'll be doing the in-text question, and I'll be solving 1 or 2 problems of your NCERT textbook exercise also. So if you found this video helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.